I'm Naima.
And I'm Nicole.
And our project is Crazy Crystal Creations,
How to grow the best and the largest
crystals.
Naima, do you know how temperature affects how crystals grow?
No, I don't. But if I had to make a hypothesis, I say it will grow better in a warmer environment because the particles grow and move faster in less cold temperatures.
Naima, what materials do we need to perform this experiment?
Well, we need a large bowl, ice cubes, enough to fill that large bowl, water, a thermometer, string, scissors, pencils, 3 of them, large jars or drinking glasses, 3 of them, a cooking pot with a lid, measuring cup, borax, a tablespoon, and plastic wrap.
Background information. Chemists perform chemical reactions as a way to change one chemical into another. Sometimes chemical reactions form more than one product, though, and chemists need a way to separate and remove the product they want from all of the other material. One way they do this is with a process called recrystallization. The scientist dissolves the mixture of products in hot water and then lets the mixture cool. As the mixture cools, one product slowly appears as crystals, which can then be removed from the rest of the liquid, which has the other product.
After the water is done boiling, you turn off the boiler, and this is when you use your borax. You keep adding tablespoons of borax into the boiling water until the borax no longer dissolves.
Now we're going to prepare the ice bath. You fill the bowl up halfway with ice, and then with water until it's 3/4 full.
We're now going to take the temperature of the ice bath.
Now we're going to pour a cup into each and pour them into each large drinking glass. Okay.
All right.
Now we're going to pour it into the large drinking glass.
Okay. Next, you tie your string onto the pencil and lower it into the cup. After that, you place plastic wrap over it. This one's going to go in the ice bath, which we figured out was at the temperature of -4 degrees. And you do the same with the other 2 cups. Before you put the cup in the refrigerator, make sure you take the temperature of the refrigerator. After you're done preparing the second cup, place it on the counter and have it at room temperature degrees, which is 69 in my house.
Now you take the thermometer out and see what the temperature is. It is 37 degrees Fahrenheit.
After you figured out the temperature, you place the last and final cup into the refrigerator. And close and let it wait.
After 17 hours, you take your crystals out of all of the places they're supposed to be. And we refilled the ice bucket about 3 times.
Our conclusion is that the crystals grew more consistently in the ice bath because in all 3 trials, crystals grew, therefore causing more crystals. Also, the crystals seemed to clump more in the ice bath than in the others. And in the refrigerator and at room temperature, only 2 of the trials worked. Our hypothesis was not supported because the room temperature was not as consistent as the ice environment, and also had less crystals clump onto the string. We think the cause of error was that the string was not tied the same length on all of the pencils, so some strings were submerged deeper than the others, causing the shorter ones to not really collect crystals. If we were to do this experiment again, we would make sure all of the strings are submerged into the water equally. We learned from this experiment that crystals can easily be made from borax, but how the crystals look and how many crystals there are depend on the environment, which in this case, ice is the ideal environment.